2000 AMC 10 problem number 1. In the year 2001, the United States will host the International Math Olympiad. Let I, m, and o be distinct positive integers such that the product of I times m times o equals 2001. What is the largest possible value of I plus m plus o? Pause the video for a second and see if you can figure it out. Drop a comment below if you did. 2000 AMC 10 problem number 1. Here's some quick tips. Read a line and then act on it. So don't read the entire problem at once. Annotate, which is to circle, box, underline, etc. Also, relax. Don't overthink it. Also, a quick disclaimer, there are multiple ways to solve any math problem, especially with AMC. The method I use is definitely not the only one, so if you can come up with another more fun or effective way to solve it, please leave a comment. In the year 2001, the United States will host the International Math Olympiad. Let I, m, and o be distinct positive integers such that the product of I times m times o equals 2001. What is the largest possible value of I plus m plus o? So first, I'm going to annotate the question by circling 2001 because it's definitely important in this problem because 2001 is the product of I times m times o. I'm going to box the variables I, m, and o along with distinct positive integers and product. I'm also going to underline the question, which is what is the largest possible value of I plus m plus o? Personally, I find it helpful to underline the question because then I have a clear reminder of what I'm supposed to be solving for. The main concept that I used to solve this question was prime factorization, which is a process to find the prime factors that make up a number. So I found the prime factorization of 2001, and a quick trick that works in every case, but there's one condition. If you add up the digits to any number and you get a multiple of 3, that means that number is divisible by 3. So in this case, if you add up the digits in 2001, you get 3, which is also a multiple of 3, which means that 2001 is divisible by 3. So I broke up 2001 into 3 and 667 and split that up into 23 and 29. However, that wasn't necessary for this question because the question is asking for the largest possible value of I plus m plus o. Because of this, I'm going to need the largest factors to get the largest possible sum. In my prime factorization tree, the largest factors that I have are 3 and 667. However, there are 3 variables, and so a quick solution to that is that you can multiply 667 times 3 times 1 to still get an answer of 2001. The final question is what is the largest possible sum of I plus m plus o, which means we add 1 plus 3 plus 667 and get 671. Therefore, the final answer is 671.